Okay, with this lecture, we will be concluding our study of normalization by taking a look at third normal form. So as with second normal form, we will try and understand what is third normal form, when do you need to go to third normal form from second normal form, when is second normal form not sufficient, so when do you need to move on to third normal form, and of course, how do you go to third normal form. So we will take a look at all of those. And so basically we are taking a look at the third normal form, as I said. Now, just like in the case of second normal form, we had found out that a fundamental concept there associated with the second normal form was partial dependencies. So functional dependencies are the conceptual foundation that allow you to examine a table rigorously as to whether it has anomalies or not. And in the case of the second normal form, we had identified that partial dependencies were at the heart of the problem. That was what was causing the anomalies. Now, when we get to a more detailed discussion of third normal form, we will come back to functional dependencies, and we will find that a particular type of functional dependency called a transitive dependency is the source of the problem that gives rise to anomalies even in second normal form table, and that's what will motivate us to go to third normal form. Okay, so we'll come to these definitions in a little. We'll come back to them. I think it's better to start with an example. So let's go back to the example where we left off with second normal form. So let me see, where's my laser pointer. Okay, good. So when we are discussing second normal form, we started with a table here, an employee project table. That was in first normal form, and we had a little discussion of why this table is not okay. It has it's an ill patient. It has anomalies. It says insert, update, and delete anomalies. To fix that in a rigorous way, we identified functional dependencies. And then from that, we identified the partial dependencies and then split this table up into three. So this collection of three tables was what resulted from taking the original table and putting it in second normal form. So the end result is three tables, each of which is in second normal form. And you remember the definition of second normal form. A table is in second normal form if it is in first normal form, plus there are no partial dependencies. And we checked that in the last presentation, in the last video, but let me just point it out again. If I look at the project table, there is project number determines project name. In the employee table over here, all these other columns, the non-key attributes, are fully dependent on the primary key, and they have to be fully dependent because the primary key is one attribute. So there is no question of having a partial dependency. Now, when it comes to this third table over here, both the project manager column attribute and the assigned hours attribute, they are the non-key attributes. Both of these non-key attributes depend fully on the composite primary key. They don't depend on any one piece of the key. So they are fully dependent on the primary key. All that means, it's a fancy way of saying, unless I know both elements of the primary key, unless I know both the project number and the employee number, I can't tell you the value of the I can't identify a row uniquely in this table. Okay, so here we are with three tables that are in second normal form, each of which is in second normal form. Okay, now we'll take a deeper look at the three tables and ask ourselves, is second normal form okay, or do these three tables still have some problems in terms of anomalies? And if they do, what do we do about it? Okay, so here were the three tables, and you remember that project number and employee number together was a composite primary key for this third table. However, project number by itself in this third table was a foreign key that connected the table to project, and employee number just by itself, that attribute, is a foreign key that connects this third table to employee. All right. So now let's look at these tables individually and say, okay, we know that each of these are in second normal form, but do they continue to have some insert, update, and delete anomalies? Okay. Now, think of the project table. If I want to add a new project, what do? I just I would know the project number, and I would know the name of the project, and I could add a new record over here, isn't it? If I wanted to delete an existing project, it exists in only one row, so I go to one row and I delete whichever project I want to do. If, say, for whatever reason, the name of a project changes, okay, so let's say project 22 changes its name, okay, there is only one place that I have to make that change, namely here. There's not multiple places that I have to make that change. All right. So this table doesn't have insert, update, or delete anomalies. So in terms of the illnesses of the table, so to speak, this table doesn't have any illnesses. Okay. And you will find that the same is true for this third table. But let's look at the employee table with all these columns a little more detail. Okay. So here for this employee table, as we said, the primary key is employee number. Meaning if I give you a value of employee number, you can identify any row in the table uniquely. All right. So let's say I want to add a new employee. That's not a problem. I will know the name, the number of the employee. I would know the first name, middle initial, and last name. I may not know, even if I don't know the job class of the employee. Let's say we just hired the employee. We haven't assigned the employee to be a database designer or a programmer or an application designer. So I don't know either of these two values. That's perfectly fine. I would have the employee number, the new employee's number. I would put that in here. I would put their names over here. And I would have null values for these other two columns. And I add the new employee. So adding a new employee is not a problem. Okay. So I have the primary key to add the new employee. If I want to delete an employee, same thing. I'll tell you, if I tell you delete employee 106, there is only one row that corresponds to employee 106. So I would go to that particular record and delete that particular record. If the name of an employee changes, let's say Alice Johnson, again the last name changes, then I just go and there's only one place I need to make that change. All right. So when it comes to employee information in this table, now this table has information beyond just the employee name, so we'll get to that in a minute. But when it comes to simply the employee details, so there is a portion of this table that doesn't appear to have insert, update, or delete anomaly. It's good in that sense, okay? But if you look a little closely, there is another piece to this table that has problems. Okay. So let's say, for example, database designer, the hourly charge is 105. So any row in which database designer appears, the hourly charge is 105. So look at this first record, this third record. Where is, I think I saw another one. Okay, there doesn't appear to be another database designer. But let's take application designer. Wherever application designer appears, the hourly charge is $48.10. Here again, you see $48.10. So if I just look at the data in the table, what the data is suggesting to me is that the hourly charge depends on the job class. So any database designer will charge $105 an hour. Any electrical engineer will charge $84.50 an hour. So in terms of our, you go back to the last lecture, go back to our definition of functional dependencies. Remember we had written functional dependency as X, right arrow Y. X is a determinant. X functionally determines Y. That's what this symbol means. Or if you say it in reverse, Y is functionally determined by X. So for the pieces that we have discussed so far, employee number determines employee name, etc., etc. But this discussion that I've just had for the last 4 or 5 minutes about job class, what I said in words is that every database, anytime I see database designer, the hourly charge is 105. Anytime I see systems analyst, the hourly charge is $96.60. I'm sorry, $96.75. Okay, so it appears just from the data that the job class determines the hourly charge. So this is your X and this is your Y. Oh, let me write that more cleanly. Just erase this guy and write it a little more cleanly. So this should say Y. All right. So this situation that we have here, why is this a problem? Right? So let's now why is this a problem? First of all, this type of dependency X to Y is a special type of dependency that we haven't yet encountered. Why haven't we encountered? So employee number functionally determines job class. So if I tell you 104, employee number 104, you can immediately tell me the job class of that employee. Okay, so the primary key determines the non-key. That is why it's there in the table. However, we have a non-key determining a non-key. This is not something that arose with the second normal form. So here, this is what is called a transitive dependency. All right. So if I just looked at this table and all I knew was second normal form, the logic I would say here are the dependencies. Employee number determines job class. So this fellow determines job class, and I would also say employee number determines charge hour. Employee number also determines charge hour. Now both these two are non-keys, job class and charge hour. Now based on the data that we have just examined and the discussion that we went through with it, job class also determines charge hour. So we have a non-key determining a non-key. So the reason that employee number determines charge hour, is because A determines B and B determines C. So employee number determines job class determines charge hours. And that's why indirectly employee number determines charge hours. So this is what's called a transitive dependency, the friend of my friend type of argument. Okay. Now why is this a problem? Why are transitive dependencies a problem? So second normal form did not take care of transitive dependency. It only took care of partial dependencies. Now we are just seeing that this is a transitive dependency and it's a problem. Why it's a problem? So let's say that the design engineer, the database designer's hourly rate, let's say the company decides to bump it up to $115 an hour instead of 105. So how many places would I have to make that change? Here is one row that I would have to make the change. Here's the second row where I would have to make the change. So there are multiple rows in which I would need to make that change. Otherwise, I would have inconsistent data. I would have one row saying that database designer charges 105, another row saying it's 110 or 115. So we'll have inconsistency. Redundancy always results in can cause update anomalies. Okay, so here you have a situation where there's an update anomaly. Now let's say I have a new job class. So here we have programmer, database designer. Okay, so let's say I have a new job class called requirement analyst. So it's somebody who knows a lot about the business and can extract the requirements from the client. So out of these different job classes, I introduce a new job class, requirement analyst, right? And let's say the hourly charge for the requirement analyst is $200 an hour. It's a very specialized skill, so it's $200 an hour. So I want to reflect that fact in the database, the fact that I have a new job class whose hourly rate is $200 an hour. I cannot do that until I assign an employee to that job class, because in order to put any record into this table, I need to know the primary key, and the primary key is employee number. So until I assign an employee to the new job class, I simply cannot record the fact that there is a new job class. So this is an example of an insert anomaly, isn't it? The flip side, we've seen that this transitive dependency results in update anomaly and an insert anomaly. Now think of the reverse situation. Suppose I have one employee who is a very special skill. Let's say, so I have one employee. Let me pick up the pen here. So let's say somewhere in this table, I have a record that looks like this. Okay, I have an employee, let's say 156, and this employee is a requirements analyst. So this employee is the only employee in my organization who is a requirements analyst. All right. Now, if this employee leaves, so I would need to delete that employee's record 156, right? And what would be the unintended side effect of that? The unintended side effect of that would be this requirement analyst position with this $200 hourly rate. That information would get removed also. So just the fact that this employee left, the effect of that is I also lose information that there is a job class called requirements analyst whose hourly rate is $200 an hour. So this is an example of a delete anomaly. Okay, so the upshot of this little discussion that we had is that transitive dependencies can result in update, delete, and insert anomalies. So and transitive dependencies are not taken care of by second normal form, as we just saw over here. So this patient is still sick. The patient is still sick, so we need to give some medicine to it, and the medicine that we will give is to take the relation from second normal form to third normal form. So as you might guess, what makes a relation be in third normal form? It must be in second normal form and not have any transitive dependencies. Okay, so that's sort of the narrative discussion. Let's summarize, put all that together in a compact way. So I've just come back to one of the earlier slides which I had skipped when going to the example. So when is a relation in third normal form? A relation is in third normal form if, first of all, it's in second normal form. So the normal forms build on one another. You can't just jump directly to third normal form. So it first of all have to be in second normal form. And then every non-key column, that means non-primary key column, depends only on the primary key. Okay, so there are no transitive functional dependencies. In a third normal form relation, there must not be any functional dependency. All right, like a transitive dependency is A to B, B to C, therefore A to C. Okay, so this is a transitive dependency. So the definition of a relation in third normal form is it must be in second normal form, and there must not be any transitive dependencies. Okay. So now let's examine each of these three tables which were in third normal form and see if they are each of these tables was in second normal form. So let's examine them and see if they are also in third normal form. We already know that this third table here, this employee table, employee project table is not in third normal form, but we'll examine it rigorously and see how we can identify that. So here is the first table. So project number, project name. This table I know is in second normal form. Is it also in third normal form? Yes, because here is the non-key attribute, project name. It is not transitively dependent on the primary key. So transitive dependencies only arise if you have at least three columns, because you need this sequence of A to B, B to C. Otherwise, the issue of transitive dependency does not arise. Okay, so this project table, which has two columns, is in third normal form. And we know that it doesn't have insert, update, and delete anomalies like we discussed a little while back. Okay. Now let's look at the project assignment table. This was the table in the middle. So the primary key is this composite primary key. Okay. This table is already in second normal form because there are no partial dependencies. This column PM, this non-key, is dependent on the full primary key. this last column, assign hours, is also dependent on the full primary key. So there is no partial dependency. We know that this is already in second normal form. Is it also in third normal form? Yes, it is, because there is, if I look at the two non-key attributes here, PM and assign hour, one does not determine the other. There is no functional dependency between non-key attributes in this table. Okay, so this table is also in third normal form. Okay, so now we'll look at the employee table, and that little discussion that we had 5 minutes back tells me that this is not in third normal form. But let's look at the functional dependencies over here. So if we parse out the details, so here's the table in second normal form. Here are all the columns, 1, 2, 3, 4, 5. There are 6 columns. So if I wrote this second normal form solution out in text form, I would say employee, that's the name of the table. Employee number, that's underlined, that's the primary key. And then you have all these other non-key attributes: employee first name, middle initial, last name, job class, and charge hours. All these non-key attributes. So here's a list of the non-key attributes. Okay. So what we are looking for is, once I know remember we said in the previous lecture that functional dependencies are the key to rigorously examining tables for these anomalies. So now for the third normal form, we are checking, are there any dependencies between two or more non-key attributes? So non-key to non-key dependency, is it there? And in this case, we do. The discussion that we had a little while back tells me that job class functionally determines charge hour. That means if I know job class, one value, so remember the x's and y's that we had. Here's your x, here's your y. So the definition of a functional dependency was one value of x is associated with at most one value of y. Meaning if I know x, I know y exactly. And that's the case over here. If I know the job class, I know the hourly charge. Okay. So here you have a situation where you have two non-key attributes that have a functional relationship between them. So then I know that this table is not in third normal form, and it can give rise to insert, update, and delete anomalies. So how do I deal with that? How do I fix that illness? Okay. And the way you fix it is by removing the non-key to non-key dependency. Remember when we went from first normal form to second normal form, and we asked ourselves, how do we do that? The source of the problem there was partial dependencies. So in order to go from first NF to 2NF, we removed partial dependencies. Now the discussion that we just had tells me that transitive dependencies are the source of the problem, source of the update, insert, and delete anomalies. Transitive dependencies are not taken care of by the second normal form. So now to get to third normal form, I take the table that is already in second normal form and I remove transitive dependencies, non-key to non-key dependency. Okay, so how would I do that? I would create a new table called job charges. The primary key would be job class and the non-key would be charge hour. Okay, and job class is a primary key in the job class table. It's a foreign key in the table employee. Okay, so for instance, if I ever wanted to know, let's say, what's the hourly rate for employee number 105, I would start from this table, employee 105, and I would use the foreign key here. This is the foreign key to jump over to the related table, and I would know that the hourly rate for Alice Johnson is $105 an hour. So the foreign key must be there, otherwise you can't. You lost the association between the two tables. But now, if you look at the structure that we have here, if I want to add a new employee, I can just add a new employee. That I could do in the second normal form table as well. But now that I have this new table, which has the job charges, if I have a new category of employee, let's say, like we said, requirements analyst, I could just add the requirements analyst at $200 an hour as a new record in this table without having an employee who's assigned to it. Okay? So I don't have an insert anomaly. Similarly, if the hourly rate for a database designer changes, I would just need to change it in one place, unlike in the previous table where I would need to change it in more than one place. So there is no update anomaly. Okay, and the same thing you would have with a delete anomaly. If an employee leaves, an employee leaves. That doesn't have any effect on on the job categories. Okay, so remember that example that we had. We had one employee who was a requirements analyst, and if that employee left, then I also have to remove the information about the requirements analyst position having a rate of $200 an hour. That problem no longer remains now. So if I have one employee who is a requirements analyst, that employee can leave. I can delete that employee from this table. But the fact that I have a position called requirements analyst at $200 an hour, that record can still remain here. It's not a problem. So by going from second to third normal form, the problem that arose with transitive dependencies has been taken care of, and in my resulting tables, I no longer have update, insert, and delete anomalies. Now, there are very special circumstances in which even third normal form can result in insert, update, and delete anomalies, which is why you have higher normal forms like fourth normal form, BCNF, and so forth. But for 99% of our needs in business applications, as long as you put relations in third normal form, you should be good to go. It's like not fixing a patient 100%, but you got a patient to a very good healthy condition, and that's acceptable to function for the database. Okay. Okay, so this is a diagram of the overall. We started from the original one table that was in first normal form. We went to second normal form, and here that one table has now been broken up into a collection of 4 tables. We know what the primary keys are for each of the 4 tables. Equally important, we know what the foreign keys. It's not enough to just split the tables into multiple tables just to get rid of anomaly, because I need to be able to make the connection back. Meaning, if I start with a project and I want to know what are all the positions associated with the project, if I want to know who are all the employees associated with the project, I need to be able to move from one table to the next table. So this is a database that consists of 4 related tables. And the way you connect or you relate tables in a relational database is through foreign keys. So make sure you understand not just what the primary keys are, which are the basis for the functional dependency, but also what the foreign keys are, because ultimately in order to put Humpty Dumpty back, you will need the foreign keys to make the connections back again. Okay. All right. So this slide just simply summarizes in words for you the steps that we went through to go from second normal form to third normal form. So to make sure that a table is in third normal form, first of all, make sure that it's in second normal form. Okay. So the only thing I need to do is examine a relationship that has a transitive dependency. If a relation doesn't have a transitive, if a relation is in second normal form and it doesn't have a transitive dependency, it's automatically in third normal form. Okay. Now, only if there are transitive dependencies do I need to examine it and then clean it up. So how do I clean up? For each of the non-key to non-key dependencies. So here you have, let's see. So here's your X. Here's your Y. So for each of the tables that have transitive dependency, identify the transitive dependency and create a new relationship for each of those transitive dependencies. All right. And the primary key of the new relation will be the determinant of the transitive dependency. So let's go back to the way we cleaned up. So remember, the transitive dependency was from job class to charge hour. That's what the transitive dependency was. Here, this is what the transitive dependency was. Non-key, that's the job class, to charge hour. So you have a transitive dependency from non-key to non-key attribute. Okay, so we make X the primary key and Y the non-key in the new table that we create. That's what we've done over here. So this slide just summarizes the steps that I had described in the narrative so far for the last few minutes. And here's the definition we have mentioned this definition of the third normal form. A table is in third normal form if it is in second normal form and it contains no transitive dependency. So there are no non-key to non-key attributes. It shouldn't say R over here. There should be a right arrow. Okay, non-key to non-key attributes. So let me clean that up. That's a typo. It should say non-key to non-key attributes. So no transitive dependencies in a table that's in third normal form. Okay. All right. So this wraps up our discussion of normalization. So to summarize, okay, let me just I'll use an example to we've seen separate videos, first normal form, second normal form, third normal form, and we've looked at each step separately. Let's sort of put it together in one journey. So start to finish, what might the journey look like? Okay. So here we have a picture in which the starting point, oh, let me get the pointer. So the starting point is a table that is unnormalized. So I have these different, so it is A, B, C, D, E, F, G, H are columns in a table. So think of this diagram as a table consisting of 1, 2, 3, 4, 5, 6, 7, 8. So 8 attributes. However, 3 of these attributes are repeating groups. That means if I look at these 3 columns, they can take multiple values. They're multi-valued attributes. Okay, so this table is not in first normal form. So for a table to be in first normal form, it must meet the requirements of a relation, meaning that the column name should be different and all of that. So that's easy to do. Okay? Getting column names to be different and all that. So that those basic requirements of a table being a relation, that's fairly easy to fix. The first substantive step you need to take in order to make a table a relation is get rid of repeated groups. Okay? So you recall from the first lecture in this series, how do we get rid of repeated groups? We create a table that contains these 3 attributes and the primary key. The primary key is A over here. And I put each of these repeating groups in a separate row. So all these multiple instances of these repeating groups, I would just put one below the other. So if you can go back to the first lecture and see an example of how we did that. Okay. So this block over here, this repeating group, becomes multiple rows over here. And I think you may remember we said one of the consequences of doing that is you end up with a composite primary key. And that's exactly what has happened over here. The primary key of this entire table is A. So I have A as the primary key, but I also have F over here. Okay. And these arrows that you're seeing are the functional dependencies. So what this tells me, what this is supposed to signify for us, is that A and F together determine G, A and F together determine H. So we have composite key over here. Now, so we have dealt with the repeating groups. The rest of the table needs to be created separately. So I have A, B, C, D, E. Those are the remaining columns. A is the primary key. So I have these remaining columns. So now, starting with these repeating groups, I now have these 2 tables that are both in first normal form. How do I proceed from there? So when I look at the table on the right-hand side, it is already in second normal form. Okay, why is that? Because if I look at the non-key attributes, they are dependent fully on the primary key. Now, the primary key happens to be one attribute, so the issue of partial dependency doesn't even arise. But if you want to have a complete discussion, we can easily say that each of these 4 non-key attributes is fully dependent on the primary key, not on a part of the primary key. So this table on the right-hand side is already in second normal form. All right. However, this table on the left-hand side is not in second normal form, because what does this diagram tell us? This diagram is telling us that A and F together determine G and H, but I also have F determining H. So do you see I have a partial dependency? What we're saying is a part of the primary key, namely F, determines one of the non-key attributes. So this is a partial dependency. And we have seen from our previous examples that partial dependencies result in anomalies. Okay. So what do? You create new tables that get rid of the partial dependencies. Okay. So here's the partial dependency F and H, F determining H. So I pull that out and I create a separate table. For this table, F is the primary key. Okay. And what remains is this composite primary key AF and the remaining non-key attribute G. So I hope you saw how these how this table was broken up into 2 tables in second normal form. Now I know that the picture says third normal form. We'll come to that in just a second. So once you split this table up, you get two tables in second normal form. Then you ask yourself, do each of these two tables, are they also in third normal form? And if I look at this table over here, G is the non-key attribute. It depends fully on the primary key. The primary key is composite. It depends on the whole primary key. That's what this picture is showing. Therefore, this table is not only in second normal form, it's also in third normal form. All right. This other split that we had, F is the primary key, H is the non-key attribute. Since the primary key is only one attribute, there is no question of there being a partial dependency. So the second table is also in third normal form. All right. And if you take your time and look at this other split over here, so I have the second split from the first level. This table is in second normal form. We had a discussion of that because the primary key is just one attribute, so there cannot be a partial dependency. So this table is in second normal form. However, this table is not in third normal form because I have a transitive dependency. This picture is telling me that A determines E, but D also determines E. So the reason A determines E, the reason I have this guy is that I have a transitive dependency. What's actually happening is A determines D and D in turn determines E. So because of the transitive dependency, A is indirectly determining E. And we know that transitive dependencies cause anomalies, insert, update, and delete anomalies. So what do? You split the table, you pull out the transitive dependency. So you pull out this dependency called DE. So that's what I've pulled out here. And that's these four columns are what we mean A, B, C, D. Okay. Now if I look at these two pieces separately, each of them does not have transitive dependency. So at the end of this entire journey, I started with a relation that was in unnormalized form and ended up with a collection of 1, 2, 3, 4 relations, each of which is in third normal form. And as we have said before, for most business applications, going up to third normal form is usually more than enough. But just be aware that there are some unusual circumstances where even when a relation is in third normal form, it could still have update, insert, and delete anomalies, and those have to do with the relations among candidate keys and so forth. So we'll not get into those, but just I want you to be aware that strictly speaking, this is not the end. Third normal form is not the end of the journey. There could be, again, infrequent to rare, unusual circumstances where you need to go to higher normal form. But for purposes of this class and for most business applications, taking a relation to third normal form should take care of the anomalies, insert, update, and delete anomalies that can